Today is December 13th, 2011. We're on lesson 6.5. We're transforming the sine function. So that wave we've been working with that looks like this, we're going to be moving it around the graph. Okay? Now, in your book, they've written the formulas that you need to remember as these two here. F at x is equal to sine x minus c, and f at x is equal to sine x plus d. I wrote the exact same formula with a different variable in place of theirs, just so we can relate it back to when we transform parabolas. Okay? I want you guys to think of that. It's very, very similar. So, I've replaced the c with an h and the d with a k. Okay? And I want you guys to remember this. I would always highlight this blue and this one green. Does anyone know what an h movement deals with? The x-axis. And it deals with moving something left or right. Yeah. What about k? Which axis does it deal with? Good. It deals with moving things up and down. Okay? That's why I used those letters. Now the book, again, is going to refer to things as C and D. I want you just to think of them as the H and K that we use with parabolas. It's the same idea. We're shifting things left, right, up, and down. So, what we have is we're dealing with our original function, which is f at x is equal to sine x. And we're going to be moving it around the graph. So, with this function, if you remember, we talked about the 5 key points that were important. One of them was at 0 and 0. 90 and 1, 180 and 0, 270 negative 1, and 360 and 0. So essentially we have a wave that goes like this. Okay. Now we're going to continue this graph because technically it continues. At 450, what number will we be at? We'll be at 1 again. Okay. And we're going to continue in the other direction, the exact same pattern. That wasn't very well done. I'm going to fix this part. Okay, so we have our sine wave. And remember, if at any point you have no idea where the points are to be plotted, you can use your calculator to solve it. If I'm at the point 90, if I hit sine, it tells me the y value, 1. Okay? So, if I don't know how to graph this, at 90 and 1, I know I have a coordinate. Say that I'm at 45, and I want to figure out where 45 is, which is between 0 and 90. We would do 45 sine, right, 0.7, so it's close to 1. Say we're at 0, and I need to figure out what sine is. My y value is 0. If I'm at 270, and I need to find my sine value, the y value of it, negative 1. So, if you ever can't remember, you can plug it into a calculator to find all the points of this wave. Okay? Now, this is the more difficult part. We're going to be transforming this wave. The first one we're going to deal with. So, first one we're going to deal with is I'm going to write a function that says, and we'll write it in blue. We're going to deal with f at x is equal to sine x plus 3. Okay? So plus 3. What I want you guys to do, in order to do this easily, is remember those 5 key points we talked about. I'm going to write their coordinates down because you needed to know them. 0 and 0. 90 and 1. 180 and 0. Yep. 270 and negative 1. And 360 and 0. Now, these are the key points on the original graph. I've given you a new equation, sine x plus 3. I want you guys to relate it to the two equations we have here. Is it a k value or is it an h value we're dealing with, the number 3? You're right, this is a k value. Okay. K deals with shifting something up and down. If K is positive, we go up. If K was negative, we would shift the function downwards. Okay. So, because K is positive 3 in this one, the entire sine wave itself, all right, so I'm going to try to outline it. This sine wave has moved up 3 units. Okay, so this is a rough sketch. We're going to find the exact points. Because I have our original, all I have to do is take my major points, and in fact, maybe I could use these 3 major ones we had. I'm going to move them up 3. So instead of being at 0 and 0, I will be at 0 and 3. I took the y value and I added 3. Okay? So we had 0, and 0 plus 3 is 3. So we've moved one of the points up 3 units. We could do the same thing from there. 90 and 1, because my y value is 1, if I add 3 to it, I'm now at 90 and 4. 180 and 0, 0 plus 3 is 3. 270 and negative 1. If I add 3 to that, I'm actually going to be at just positive 2. And if you notice, we're going to end up with the same shape, just at a higher point on the graph. So we can continue that pattern too. We know that at negative 90 we'll be at 2, negative 180 will be at 3, negative 260 will be at 4, negative 360 will be at 3 again, and negative 450 again at 2. So we continue this graph. And the wave is the exact same shape. The only difference as we've gone up 3 units because we were adding 3. Okay, with that being said, I'm going to show you the other example. We'll do this in one red. We're going to go a little quicker. Here's our next equation. Say we had f at x is equal to sine x minus 4. We start again at where our original equation is, which is our sine x at 0, and we just move everything down 4. So at 0, instead of being 0, I'm at negative 4. At 90 and 1, I'm at negative 3. I'm at 0 again, 5. So if you notice, I took our key points and I just subtracted 4 from them. If we continue that pattern, we have the graph of our sine wave. The only thing is that we've now moved this down 4 units, okay? So the blue one, which was our positive 3, that was this equation here. We moved the entire wave up 3 units. Our red equation was minus 4. We moved the entire wave down 4 units. What's very important is you have to know how to draw the original one in order to go from there. Now, I'm going to show you a trick. If you are really stuck and you're confused, you can solve this on your calculator the same way. Now, my calculator doesn't show this stuff as nicely, but if we plug in the function sine x minus 4, so say I'm at 90. I got to find out when x is 90, I push sine and then subtract 4. That gives me my y value. My y value is negative 3, which we found right here. Okay? Same idea if it was sine x plus 3. If I'm looking for 90, I plug 90 in for sine, and then I add 3 at the end. It will give me my y value, which was positive 4. So, with the same information I gave you the original one, you can plug in to solve our other 2 waves, all of the points on the graph. All right, next question. Example number 2. Again, we've drawn the original sine x, okay? Here's our wave. I know it's not perfect. This is a rough estimate of it. In our red example, we need to relate this to one of the graphs. Are we dealing with an H or a K in this one?
That's an H.
Okay.
So move that 90 over.
So this is a Washington.
Different.
It's less than 6.6.
In our next example, our red example here, we have sine x plus 90 and we discovered that it was our h. Sine x. So we have our x minus h. Now this is important. Our h, remember we deal with the entire sign in front of it. So if h is a negative number, we're moving to the left. Sorry, I apologize. To the right. We do the opposite of what it seems to be. If h is a positive number, we move to the left. It's counterintuitive, the opposite of what you would think you would do in terms of positive and negative directions. So, in our question we have plus 90. What I want us to do is every x value, I move to the left 90 degrees. So here, I would move left 90 degrees. Then I go to our next point. This point here, I would go left 90 degrees. Same with this point here. Left 90 degrees, left 90 degrees, left 90 degrees, left 90 degrees. So if you take a look, our new wave falls in between of what the old one would look like. Everything's been shifted to the left 90 degrees. So we've gone to the left 90 degrees because our function was sine x plus 90. Okay? It's very important that you realize the plus sign made us go in a negative direction. All right, in our next question, we have f of x is equal to x minus 180 minus 3. Now, you can choose to do the h movement or the k movement first. It's completely up to you. Just for the sake of our graph, I'm actually going to deal with the k movement first, just so it doesn't get all jumbled in between these sine waves, okay? So our k movement is negative 3. From our black wave, which way do we move from there, does that mean? Down 3, okay? Because we have our negative 3. So, okay, so because our k was negative 3, that means our function was going to move down. I'll do this one in a different color just so. Do it in purple here, okay? So we're going to shift everything down 3. So my original, which is at 0 and 0, if I shift it down 3, I'm at 0 and negative 3. From 90 and 1, negative 2. And I'm going to complete this pattern, okay? 180 would be at negative 3 again. 270 would be at negative 4. And we continue the waves pattern. Okay? And then we're going to head downwards, or head backwards, sorry, on our x-axis, continuing this pattern. Oh, did I not go high enough there? No, I didn't. There you go. So let's continue this pattern. Okay, so this would be the first movement. This would be the negative 3. We've now shifted it down 3 units. But the next thing we need to do is we need to shift it negative 180 degrees, or because this is an h, okay, we're saying it's negative 180. We go to the right 180 degrees. So I take my purple wave here, and I'm going to shift each part 180 degrees. Now I want you to pay attention to what this does to the wave. Okay? If I shift this 180 degrees, over 1, 2, 0 and 0, I end up at the same spot there. Now my 90 plus 180 is, anyone know? 270. So I'm now at 270. 180 plus 180 is 360. I'm over here.
What are we doing?
Same wave. Okay. We're just moving it to the right 180 degrees. Okay, yeah. If I go from negative 90, I go over 180. Here's 90, 180. I go back up. And if you notice, it kind of creates a neat design here. Okay, so a shift of 180. Our 0 points are the same. Our points that would be normally 0 would be the same. The green one has shifted 180 degrees to the right of the purple one.
So, the one that
Okay, the next part of the question asks us for the domain and range of each of these. So we're going to find the domain and range of our f at x sine bracket x plus 90. So we had this function here, and we drew it on the graph. F at x was equal to sine x plus 90. Okay. Now, the domain of this function. This is a function that goes forever. Anyone know what the domain is going to be? Yep. X is the element of all real numbers. That is the domain. Unless they've told us we're only graphing it between 2 points, this goes forever. Now the range of our function, this is where I want you guys to notice, it has peaks and troughs. Remember we talked about that before? It peaks at 1, and the trough or the lowest point is at -1. So the range of our function is a little different. Our range of this function is all the numbers in between, so YER, all the numbers in between -1 and +1. Okay, so that's our domain and range. Okay, last thing we needed to find was the domain and range of our green function. So our green function, which was f at x.
So we were finding the domain for the red one?
We already did that.
Yeah.
-3. Okay, so the domain for this function is the exact same as before. With these waves, sine waves, specifically, it goes on forever. So we are going to continuously go. There's no restrictions unless they say in the question there's a restriction. There are no restrictions on this. It exists all the way left and all the way right. Our range, on the other hand, for our green function is a little different. It has a peak at -2 and a low point at -4. So what that means is our y, the range of this function, exists in between all the points. Oh, that's the wrong one.
Is it -4?
-3, -5, -4.
So between -4 and -2 is the range of this function.